Welcome you all. Now, I would like to call Principal G. Kanakadurga ma'am, Dr. G. Kanakadurga ma'am, to speak a few words.
OBS మాట్లాడితే క్యాప్చర్ అయిపోతుంది, దట్స్ అ ప్రాబ్లం అవుతుంది.
It seems there is a network issue. Ma'am didn't join. Let me introduce our chief guest today's session, Dr. Chakravarti Bhagawati. Dr. Chakravarti Bhagawati is currently a professor and dean of the School of Computer and Information Sciences in University of Hyderabad. He received his PhD from Rensselaer Polytechnic Institute, Troy, New York. His MTech in Computer Science from University of Hyderabad, and his BTech in Electronics and Communication Engineering from JNTU College of Engineering, Hyderabad. The primary research areas of Dr. Chakravarti Bhagawati are image processing, color image processing, pattern recognition, and the popular deep learning. Although not an initial fan of neural networks, he has grudgingly accepted them to satisfy today's needs and is beginning to enjoy them. Currently, he is working on varied and diverse applications of image processing, such as content-based image retrieval, forensic analysis of documents, optical character recognition of Telugu script, and GAN-based applications. Finally, he is an avid amateur astronomer and spends several nights observing stars, planets, and galaxies with his 8-inch telescope. Welcome you, sir. Now I would like to call Dr. Chakravarti Bhagawati, sir, to speak a few words.
Thank you. Am I audible?
Yes, sir.
So, thank you, and it's a pleasure for me to come to MBSR Engineering College, even if it is virtually. I've never been there physically, by the way, so the first time is a virtual entry to the college, and I'm happy to be there. And one thing I'll say is that while definitely I thank the principal Kanakadurga, then the head of the department Prasanna Kumar Garu, and my special thanks of course to Sandhya, with whom I have many connections. First is that she did a PhD from University of Hyderabad with Professor Agarwal, who happens to be my supervisor when I did my MTech. Secondly, she is also related to yet another person who happens to be my research scholar at some point, who happened to be a research scholar for me. So in a way, we have several connections to Sandhya. So it's always a pleasure to accept her invites whenever she does this. So it's nice to be here, and this program to me seems very appropriate because deep learning has caught the world by storm. Everybody in industry, in academics, everywhere is talking about it. And there are a lot of misconceptions as well as a lot of excitement about the field. And the best way to deal with deep neural networks and deep learning, especially images and video, is simply by practicing. And it's become easy to do these programs, at least simple enough programs in deep learning, because of the availability of a lot of libraries and tools. And I'm sure with the help of Talent Sprint and then the practical sessions that the organizing team has planned for you in the afternoons, you'll have a great time. So I'll not say much except it's nice to see all of you, even if it's only virtually, and see the number of people who have joined here. It shows on my box that there are 52 people already here, and that's a really encouraging thing to see today. So thank you very much, and I'll reserve most of my deep neural networks and other things for the inaugural talk, which I'm supposed to give you after a few minutes. So thank you very much.
Thank you, sir. May I now request Vatsala Narasimhan, Principal Consultant, Talent Sprint, to speak a few words.
Thank you so much for this opportunity. I'd like to thank Prasanna Kumar sir for giving Talent Sprint an opportunity to do the hands-on session. And I would like to start by saying this quote by Alvin Toffler, the illiterate of the 21st century will not be those who cannot read or write, but those who cannot learn, unlearn, and relearn. So it is very, very interesting that business communication head. I'm director delivery and I take care of college campuses. And we do training to upskill students and get them ready for this new age. So a little about my company, and I have with me my colleagues, Surabhi and Dr. Hari, and both of them are going to be doing the hands-on session. So I would like to first introduce the organization Talent Sprint, which I'm proud to be part of and have been in this organization for 10 years now. So I'll be presenting. I just want you to let me know if you are able to see my screen. Are you all able to see my screen?
Yes, ma'am. Perfect.
So we are going to be, Talent Sprint is going to be doing the hands-on training for the Keras, using Keras for FBSR, what you have organized. So we are a training platform, deep tech learning platform for working professionals and graduate students. We work on hybrid programs on deep and disruptive technologies like AI, machine, fintech, blockchain, cybersecurity, robotic and digital process automation. And we are proud to say that we have a very strong leadership team headed by Dr. Shantanu Paul, who is our CEO. He is a PhD in computer science from Ann Arbor University, Michigan, and Sridhar is our Chief Business Officer. He has a whole lot of experience in financial services and is from Kavi. Ashok, who is considered the best in Python training, heads our learning and development. Jitendra Singh, who is an alumni of IIT Kanpur, is our Chief Technical Officer, and Gurpreet Bhatia, who is our Chief Learning Officer, has at least 20 years experience from the industry. So if you see, recently we have been acquired by the National Stock Exchange Academy. So we are now a part of the National Stock Exchange Academy. And we have deep partnerships with top-tier academic brands and big tech firms like Indian Institute of Science, IIT, IIIT, IIM, Google, Pega, Automation Anywhere, and Blue Prism. So we do a lot of deep tech programs in partnership with top institutes, and we are also training partners of top companies. So with IISc, we do the digital health and imaging and computational data science. With IIIT, we do AI and machine learning, blockchain, and data science. And these are a few of the programs that we have been doing with top-tier academic institutes. Apart from that, we do a very unique program exclusively for women in partnership with Google, the Women Tech Makers Engineering Fellows Program, and we are also the delivery partners for the Pega University Academic Program. So Talent Sprint is in a position to deliver deep tech learning for both students and professionals. So how do we work on? So Talent Sprint's unique closed loop program are designed to not empower students, also empower people who want to learn and make a difference to themselves. So we have a tie-up with global corporations. We understand the industry very well, and we also have a deep connect with colleges, and we bring both the ecosystems together. So we also have the benefit of creating our own internal platform, which is AI powered, called iPearl. So this was something that we were using internally for our training programs. And now, thanks to the the Center of Excellence network that created, where 100 universities and colleges are part of it, we opened up this platform to a wide range of students and learn from that. So this particular platform is used by IIM Calcutta, IIT Kanpur, academic program. So our TS Center of Excellence family reaches out across 17 states. And we are ready to create a world using this particular platform. So today, I would also like to introduce my colleagues, Dr. Mohammad Habib. He's the Director Delivery for Executive Programs at Talent Sprint. Habib has a whole lot of experience in dealing with AI, data science, machine learning, design patterns, and he is now heads the executive programs at Talent Sprint. He's Director Delivery for the executive programs. Dr. Surabhi Lahiri is the principal consultant for program delivery at Talent Sprint. And she comes from a farm background and has also worked as a postdoctoral fellow at Washington University in St. Louis. So I'm very happy that my colleagues who have this not only deep understanding of the subject, also have a passion to make a difference to people who are part of their participants group. I'm very happy to introduce both of them, and now I would hand over the the virtual mic to my colleague Dr. Habib, and he will briefly talk about what he will be covering during this hands-on training. Thank you very much for the opportunity. We would be more than happy to make a huge difference or an impactful difference to the participants who are part of this particular program. Thanks once again.
Okay, good morning everyone. Thank you, Vatsala. So already Vatsala introduced me, myself, Dr. Habib, Director Delivery in Talent Sprint. So we are dealing with AML and XD programs. With me, my colleague, and both are working as a principal consultants. So we, as a team 3 of 3, we are going to lead for hands-on sessions. So now in the first day, we are going to cover about AN9 hands-on in session 2 to 4 session. Second day, we are going to cover with CNN, and third day, we are having an experience like hands-on with LSTM. And fourth and fifth days, we are going to have some hands-on case studies. One is like application deep learning, case study 1, and the second one is applications on deep learning using case study 2 using Keras. In the first case study, we are going to discuss about like image processing. How do you take the label the data of training and testing images? How do you create the training and testing images for CNN? Generation of those images we are going to discuss in hands-on session. Coming to the second case study, we are going to say like how do you read the videos and using RNN on LSTM for video processing. So we take hands-on. This complete hands-on is starting with Keras. So whatever the sessions morning, whatever you are covering, in the afternoon session from 2 to 4, we are going to work on hands-on with the people. Okay. So hope you will enjoy the sessions, and I would like to see from 2 to 4. Okay then, thank you. Thanks everyone.
Thank you, Talent Sprint team. Now, I would like to call Program Coordinator Dr. Sirisha ma'am to propose her vote of thanks.
Thank you, Sri Lakshmi. Good morning, respected dignitaries and dear participants. On the behalf of CSE Department, MSR Engineering College, I would like to thank our chief guest, Dr. Chakravarti Bhagawati sir, Professor and Dean SCIS, University of Hyderabad, for accepting our invitation and sharing the pathway and opportunities in this growing world. We are honored to have you, sir, as our keynote speaker. In the row, I would like to thank AICT for providing us the frontline opportunity to conduct the short-term training program under AQIS scheme. In this COVID era, each of everything in this world has shaped in a very different view. MVSR Engineering College management is playing a key role to cope up with these things. I would like to acknowledge the support our management, our principal, Madam Dr. G. Kanakadurga ma'am, our head of the department, Professor J. Prasanna Kumar sir, who always acts as the pathfinder for us and support us in every possible way. I would like to thank our program monitoring committee for their visionary mentoring and throughout the plan. And I also want to thank our program coordinator, Dr. B. Sandhya, for guiding us all through the session to plan and conduct this mega event. Last but not least, all our organizing committee members who are the back end of this particular program and continuously working for the grand success of this STTP. So I welcome all our participants, and I hope that STTP will help you in rewiring your minds, and you'll be having some fruitful insights in the field of deep learning. Now I'd like to call Dr. Chakravarti Bhagawati sir to take over the session, sir.
Thank you. So I'll share my screen and let's see how it goes after that. Just wait while I restart one of my windows here. For some reason, the presentation died on me. I'm back. So are you able to see the screen?
Yes, sir.
Is it clear?
Yes, sir.
Okay. So I'll start. And yeah. So I'm very, very happy to see all of you here. And I'm sure many of you are excited about learning more about deep networks and then doing some programming and really getting into the basics of research in deep networks in the next few days. So I titled this as a talk that will cover the entire field of learning, machine learning per se, so that you get an idea of how this deep learning has evolved, where it came from, and where we are going to now. So the talk is titled Deep Neural Networks from the ABCs to the D in Learning. So the D, of course, is deep learning. And we'll see how this all works. So the talk will be something like, where are we in AI today? How did it all start? So we have to go back in time to almost 70 years ago when we had the perceptrons. Then after about maybe 40 years ago, we had backpropagation. And about 15 years ago, we had the beginnings of deep learning. So all these are closely related. And we'll see how we travel through time to get to where we are now. And then a very quick sort of flash through on the screen of the exciting developments. Then obviously we need to have a bit of caution whenever we look at technologies which are highly disruptive, because we don't know in what ways they'll disrupt our lifestyles and lives. And then finally, a bit of a conclusion. So we start by looking at, I thought we should all be familiar at least with our field, and these are computer scientists. So if we talk about computer science, until a few years back, most students would have heard names like these. Charles Babbage, who of course came up with the idea of a mechanical device to compute things. Then Alan Turing, John Backus, Fortran, as well as the Bacchus-Naur form. Then Dijkstra, which almost every student loves to hate because he did so many things in computer science and gave so many opportunities for teachers to ask questions. Then Stephen Cook, who came up to show that the satisfiability problem is NP hard and NP complete. So that was the first of the NP completeness proofs. Then Dennis Ritchie, the C language and the Unix OS. Winton Cerf, of course, the beginnings of the internet, packet switching protocols and so on. And then Tim Berners-Lee, World Wide Web and browsers. These sort of cover the spectrum of what many people consider the most well-known things about computer science. These are various ideas from these people that have come into popular folklore, and they're a part and parcel of most of our lives today. This is what most students would have answered about 10 years ago if we asked them about computer science. Today it's different. Today everything seems to be AI, machine learning and deep learning. So again, we have the series of people here. It all started way back in 1957 with Frank Rosenblatt, who came out with the idea of a perceptron, which was the first architecture that could mimic a neuron in the brain. Then very few would have heard of this guy, Paul Verbos. In 1975, he came out with the ideas of backpropagation. And you'll see that backpropagation is the primary learning algorithm that's used in all the neural networks today, including the deep neural networks and the convolutional neural networks. Then Hinton in 1986, along with Rumelhart and Williams, further popularized the backpropagation algorithm and actually implemented the backpropagation algorithm in a distributed connectionist architecture. So that's what gave rise to backpropagation. And again, Hinton, later in 2006, came up with modifications to the algorithm which allowed us to go in for this deep learning. Jan LeCun, credited with convolutional neural networks back in the 90s, late 80s, 90s. Yashua Bengio, Andrew Zisserman, and Ian Goodfellow are people that every student today knows. That's because these are the people who have built most of the networks, and these are the people whose teams publish most of the papers in deep learning today. So what brought us here today? I'll say that there are basically three kinds of networks which came up, and they started this revolution. The first was AlexNet, which was built by Alex Krzyzewski in Jeffrey Hinton's team in Toronto, in Canada. That was the first big success on the ImageNet database, which was mentioned earlier. ImageNet database has 1 million images and more than 1,000 categories. And this AlexNet was actually able to give a performance which was more than 15% better than the second best performance. And that started making people look at neural networks again. VGG16 from Cambridge, I think. No, sorry, Oxford or Cambridge. I always get confused. This is Zisserman's contribution along with Karen Simonian. Then image captioning, this mixed text with images, and the rest, as they say, is history. After these three networks came and showed spectacular successes, people just went completely crazy in this field. And today you'll see that almost every day are added on archive related to deep networks. Okay. So let's just, what are all the spectacular successes of deep learning in the academic and some other worlds? So let's go. So these are the famous DNNs that I've talked about. The one on the top here, this one is AlexNet. This one here is VGG16. And this one here is Inception Network from Google. All these things have a place in the history of deep learning. So I just, let's look at the simple stuff. Okay. So in most of this talk, instead of just showing the spectacular results which are published on Google or that you can get with Google searches, what I thought is just to inspire us that we can also do many of the things. I'll show examples from research work that we have done in our own university and in our own school. Okay. This is part of the research work that I did along with two of my PhD students. This is on Telugu optical character recognition. And you can see that it has done very, very well. When you look at many of you people can probably read Telugu. So you can see that except for a couple of mistakes here and there, the Telugu that it gets here is very, very good, including complex letters like Argyam, which has multiple vakus. Okay, so this is simple stuff now. You talk about this to a deep learning guy and the guy will just probably yawn and go to sleep. So that's the way it is. Simple stuff too, image generation. This is also a very, very famous image. This name is Edward de Bellamy. It's a completely deep learning synthesized painting. It sold for almost $500,000 in a New York auction. So this is also now simple stuff. Hit me at any point, okay? Then this is some work that we have done here in our own school. One of my master's students, Krishnan, did this work. He trained a deep network to come out with Raja Ravi Verma paintings. He is from Kerala, so Raja Ravi Verma seemed very appropriate for him. And I must say that these paintings, if any of you have known or seen Raja Ravi Verma's paintings, the colors in these paintings are very similar to what a Raja Ravi Verma painting would look like. The faces and the people are not yet good. That's because we don't have the computational resources that are needed to perfect them beyond this stage. But these are pretty good. You can see the colors, especially of pictures like these. These are very close to what Ravi Verma would paint in his. So these are fakes from our own school. Then again, this is a classic example that people give you. This is the not so simple stuff now. None of these faces here is a real face. They are all fake faces. Every one of them is synthesized by a deep network called a specific type of a deep network called a generative adversarial network or a GAN. So you can see that these faces are remarkably human. And if you just put this as a photo somewhere, people will believe that it is actually a photo. Right? Then here are some more interesting things. This is from NVIDIA. You just do a rough sketch like this and select what you would want these regions to be here, and you can convert them into very, very good looking paintings or photographs. That's an NVIDIA tool that came out a few years back, or they demoed a few years back. Then this is something that is our own work here again. Krishnan has done this. You just create these kinds of blobs, binary, black and white blobs, and a deep network, a GAN trained on converting these, converted them into these paintings on this side. So I'm actually quite impressed with the way these paintings and colors have come out. All these require several days of training on multi-GPU machines. Okay, so the main thing here is the kind of computational resources that we need. Otherwise, any one of us can do these pieces of work. Then here are more things. Okay? So these are, you take a lot of paintings, these are typical paintings in Van Gogh style, and you convert them into photos. This is called a style transfer. There are many style transfer networks today. So it takes in one style, the content from these photos changes the style and you get photos. This is the other way around at the bottom. These are photos that are taken and they are converted into Van Gogh style paintings. Same thing, again, you're transferring the style and the content from different people into these networks, through these networks, and you're creating paintings or photos as the case may be. Again, these are done by a master's student here in the school. Text generation, this is the famous blog from Andre Karpathy in 2015, which showed that you can actually generate pretty realistic text after training very easily with your networks. And this shows these examples of things like Shakespeare's work. And you'll see that this is pretty close to what a person who is not very familiar with Shakespeare would think of. Especially when you look at this King Lear poem, it says, "Oh, if you were a feeble sight, the courtesy of your law, your sight and several breath will wear the guards with his heads, and my hands are wondered at the deeds. So drop upon your lordship's head, and your opinion shall be against your honor." Sounds pretty Shakespearean to me. Don't ask me what it means, though. We'll leave it as a PhD problem for someone. Okay, so this is one. Then this is, now we're beginning to get to the scary parts. This is from Andrew Zisserman. Unfortunately, this video is not very clear when you project it. So I can show this video, but it will not be very clear. Okay. However, let me see. Are you still able to see my screen?
Yes, sir.
Yes?
Yeah, yes, sir.
Okay. So let me see if
No,
I
right
can
now
play.
it's blank, sir.
Okay, it has gone blank, so that's what I wanted to know. I'll change the presentation to this particular window, okay? So let me do that, and we'll get back to this. I'll change the window that I'm presenting, okay? So that you get the full view. The only reason I didn't do that at the beginning is with Google Meet, there are a few interesting issues that I have. Okay. But let me get back to this. Oh man. Something is happening here. I don't know why it's doing this. Just let me get back to this. Sorry for these technical difficulties that we always seem to have when we are doing these kinds of things. Let me get back to this. So, but the basic message that I want to give you is all these things can be done by us. We don't need any spectacular things here. And let me just get back to where I was, and then we'll do this. So let me share the screen. Now are you able to see? Let's see. Are you able to see this?
Yes, sir. Yeah.
Yeah?
Yes, sir. We are able.
Okay. So this video is very interesting because here in this video, the work is just as Google does the closed captioning of YouTube videos. This is doing the same thing, except that here the closed captioning is not done by recognizing the speech, but actually just reading the lips in the video. So the audio is actually not there in the original video. The audio is later put back to show you how well these things do. Oh, come on. These things have to work. Let me get back to another thing here. Sorry. These are technical difficulties which invariably happen when we produce videos and embed them in kind of presentations and so on. So they happen. Again, we start. Oh, what's going on? I don't know what it is presenting, but let me see. Yeah. Are you able to see the window?
No, sir, it's blank right.
Let's see if it comes. Is it still blank?
Yeah, it is still blank now, sir. Try to play the video, sir, probably.
The video you can see.
It's playing on my side. Are you able to see anything?
Which is why the President of the Polling Council, according to the latest figures from the Office.
We can hear the audio, sir. Probably there
No,
is
but we're
some.
not able to see.
Yes, sir. Yes, sir.
Okay.
Decision-making process before the invasion and during the conflict. He was
Probably
arrested.
some latency. Let us wait, sir.
Good afternoon and welcome to the
Maybe there is a latency, but
Yes, sir. There is.
Tonight, that is a very difficult situation.
let me just do one final experiment.
Manchester City travel to Paris in the Champions League this evening. West Wales and the South West, as well as Western Scotland. We have to look at whether it works for the UK or not.
The government will pay for both sides.
I don't think this is the right step to take.
Especially on the most important decision.
The process has been very reliable.
Now,
I can see the screen, sir.
are you able to see the screen now?
Yes, sir. Screen is visible, sir.
Okay. So now let me play it.
Yeah, we can see the videos.
Yeah. So the point
The
is
President of the Polling Council,
According to the
this
latest.
at the bottom. After some time, you'll see captions. Okay, and they are done by reading the lips of the speakers, not by. Yeah. Now you can see the captions.
But David Cameron has admitted tonight that is a very difficult situation.
And you know what they say about people with small.
Manchester City travel to Paris in the Champions League this evening. West Wales and the South West, as well as Western Scotland. We have to look at whether it works for the UK.
For both sides.
I don't think this is the right step to take.
Especially on the most important decision.
The process has been very reliable.
Okay, so you can see that at the bottom there are these small which are recognizing the lips, the movement of the lips. So that's a very scary thing that you can do right now. Okay, and but anyway, these are some of the things that deep learning has been able to do. So let's get back to what it is, and I'll just give you an overview of probably many of these techniques that you'll study in the next few days in this short-term training program. Okay, so are you still able to see my screen?
Yes, sir.
Oh, the question is now, how did we get here? Deep learning is a specialization of pattern recognition. And before you go to deep learning, let's just quickly look at what pattern recognition problems are. The biggest problem is something called a semantic gap. And that's very easy to explain. Because if I ask you what is there in this picture on the right side, okay, what do you say? The picture on the right. Right? So you basically see children, you'll probably guess it's a birthday party. There's a cake, there are gifts and so on. Right? This is what every human being sees. But if you program this into a computer, all the computer sees are colors, which are triplets of RGB. It sees edges if it does edge detection using Sobel, Canny, any operator. It can then group them into regions doing segmentation by any of our known methods. And then it can also talk about the coordinates of all these things. So these are what is known on the side of the computer. And none of these, remember, is directly related to either children, cake, gifts, or birthdays. Okay. In fact, there's this concept of a birthday is completely human. It has nothing to do with the picture that's there. Okay.